In this video, we're focusing on a special type of sequence called an arithmetic sequence. The biggest thing about an arithmetic sequence is that there's always what's called a constant difference between consecutive terms in the sequence. So, here's an example. We're going to decide whether or not this sequence is arithmetic. So we're looking for a constant difference. So to find a constant difference, what I'm going to do is go say 1 minus negative 3, so some scratch work. So 1 minus negative 3, so I'm just kind of working backwards. And that's positive 4. Now I want to go to the next one, do some more scratch work. 5 minus 1 is positive 4. Try some more scratch work. 9 minus 5. It's positive 4, and then a little bit more scratch work, so 13 minus 13 minus 9 is positive 4. So this difference that I'm finding is constant, so that's called a common difference. So my common difference, D, is 4. So that means yes, arithmetic. If even one of these differences was not 4, then that means I do not have a common difference, and so it would not be arithmetic. So let's do another example. The next one in red. We're going to do the same idea, just work backwards. So I'm starting off saying 10 minus 2, which is 8. Do the next one. 17 minus 10, which is 7. So automatically I can stop there. My difference is not constant. So no common difference. And so what that means is not arithmetic. It's still a sequence, but it's not an arithmetic sequence. The arithmetic sequence has to have a common difference. Okay? Now, every arithmetic sequence can be written with this rule, where A of 1 represents the term in the very first position, N is just the variable that's going to stay there, D is your common difference, and A of N is your final position that you're interested in finding. Okay, so here in example 13, what we're doing is going to write a rule for the nth term of this sequence, and then use that rule to find A of 20. So we're going to find who lives in the 20th position. So let's start off with just writing our rule. I'm going to pretty much plug in what I have here. So obviously A of 1 is in the first position, so that's going to be 50. I need to find my common difference, D, so I'm going to do a little bit of scratch work. So 44 minus 50. 44 minus 50 is negative 6. 38 minus 44 is negative 6. And then 32 minus 38 is negative 6. So all my differences are constant. So that means that my common difference, D, is negative 6. And so now I'm just going to plug into my rule. So using all of that information, my rule becomes 8 of N equals 50 plus N minus 1 times negative 6. Okay? And that's it. That's my rule. Now what I want to do is find A of 20. So let's do that in green. So I'm using this rule that I just found to find A of 20. So everywhere I see an N, I'm putting in a 20. So I have 50 plus 20 minus 1 times negative 6. Now I'm going to use my calculator and just clean this up. So clear it out. So 50 plus 20 minus 1 times negative 6. And I get negative 64. So that means... So what it tells me, in the 20th position of this sequence, negative 64 lives there. Okay, let's move on to a more complicated example that's going to build off of this rule, this general rule. Alright, so here we're told that one term of an arithmetic sequence is, in the 13th position we have 30. The common difference is 3/2. We want to write a rule for the nth term of the sequence. Okay, no big deal. So first off, let's start. We're told that the sequence is arithmetic. The sequence is arithmetic. So what we know is that we're going to have to use this rule. A of n equals A of 1 plus n minus 1 times d. Finally, let's plug in what we do know for a fact. So we know that A of 13 is 30. So if n is 13, we know that 30 goes here. A of 1 we still don't know. Plus, again, n is 13 minus 1, and our common difference is 3/2. Now what we can do is go and solve for our first position. Okay, so this is like our variable that we're trying to find right here. A of 1 is what my target I'm trying to find. So I'm going to just clean stuff up as much as I can first. So over here I'm saying 13 minus 1 times 3/2. Again, that fraction needs to be in parentheses. And I get 18. So I have 30 equals A of 1 plus 18. All right, so now it's a very easy process. We're just going to subtract 18 on each side. So we have A of 1 is 12. So that tells me that in the first position of this sequence lives a 12. Now, you don't need to divide by 1 or multiply by 1 or subtract 1 or anything like that. That A of 1 is part of the symbol, part of the variable that we're trying to find. It tells me who lives in the first position, so keep that 1 there. Okay, now that we know who lives in the first position, we can go back to our general rule and write a rule for the nth term of the sequence. Okay, so we're actually finally able to address what we're being asked to do. So I have A of n equals our first position, so 12 plus n minus 1 times 3/2, which was our common difference. That's my general rule. That's going to let me find any term in the sequence if I know what position n it lives in. Let's do another rule, another example. Here we have two terms of an arithmetic sequence. Are A of in the 6th position is 10, and the 21st position is 55. You want to write a rule for the nth term of the sequence, and then use that rule to find the value of n when A of n is 40. Okay, so first we want to figure out what is our first position. Since we know that it's arithmetic, we're going to start with A of n equals A of 1 plus n minus 1 times d. Now what we're going to do is use the information that we have. Okay? So the information that we have says in the 6th position, so when n is 6, I have a 10. So 10 equals our first position plus 6 minus 1 times d. Okay? Now, I also know that when n is 21, 55 lives there. Okay, so I have 55 is equal to my first position plus 21 minus 1 times d. Alright, so now what I want to do is to clean this up, each equation up as much as I can. So this equation here is going to become 10 equals my first position plus 5d. The second equation is going to become 55 equals my first position plus 20d. Now, this is actually a system of equations. You should know how to solve a system of equations by hand using elimination, or by using substitution, or by using a calculator graphing. I'm going to do graphing, but before I do that, remember, a calculator only likes x and y, so I'm going to do that. Okay, so here I'm going to pretend that a sub 1 is equal to x. So when I type in my calculator, when I see a sub 1, I'm going to type in x. And everywhere I see a d, I'm going to put a y. Okay? So that means that both equations now become, so my top equation becomes 10 equals x plus 5y. My bottom equation becomes 55 equals x plus 21. And we've seen stuff like this before in previous classes. What we need to do is to get y by itself. So you should know how to do that. I'm not going to bother with that scratch work, but the top equation becomes 10 minus x, all of that divided by 5 is equal to y. Now, there's going to be more than one thing on top, so I've got to have parentheses around 10 minus x. The bottom equation becomes 55 minus x divided by 20, and that's going to be equal to y. Now that I have both equations, I can graph y1 for the first equation, y2 for the second equation. Alright, so I'm going to go to y equals, type it in. Again, don't forget the parentheses. So 10 minus x divided by 5. And y2, I've got 55 minus x divided by 20. Okay, I'm going to graph. Every time you do a new picture, hit zoom 6. And my point of intersection is about right there. So second count, option 5 for intersection. First curve, just hit enter. Second curve, just hit enter. And then guess. So my intersection is x equals -5 and y equals 3. Now, but based on this, since x equals -5, that means a sub 1, or my starting position, is -5. And my common difference d is 3. Great, so now I can plug into my general rule to find the nth term of the sequence. So I'm just using that information now. So I have a sub n equals -5 plus n minus 1 times 3. That's the rule for the nth term of the sequence. And now that I have the rule for the nth term of the sequence, I want to find what's the value of n when a sub n is 40. So everywhere I see an a sub n, I'm now going to put in a 40. And I want to solve for n. Okay, no big deal. Obviously, you could graph this if you wanted to. y1 on the left, y2 on the right. Instead of n, you would put x in your calculator. Not a big deal. But I'm going to actually go through and solve this by hand, okay? Because it's good to practice that. So I want to go back in blue and do that. The very first thing I want to do is add 5 to both sides. So I have 45 is equal to n minus 1 times 3. Now I have distributive properties, so 45 is equal to 3n minus 3. Add 3 to both sides. So 48 is equal to 3n. I didn't get n by itself, so divide by 3. So I have 48 divided by 3 is 16. I believe I'm going to double check that in the calculator in case I made a stupid mistake. But I'm pretty confident I'm right. So on my main screen, 48 divided by 3, 16. So that means, what that tells me is that when a sub n is 40, for that to be true, n must be 16. And we've answered every part of this problem. Lots of work, but you know, it's not that bad. Again, the biggest trick was to graph and define your starting term and your common difference. You had to do that to create the rule for the nth term of the sequence. And that's it for this video. I know this last example was particularly long, so I would suggest watching it multiple times. And definitely, as always, if you got questions, let me know.